Hello, I think we can start. It's 10:30. It's my first session, my first public speech after 18 months, so hopefully I will do it right with English. If you don't understand me, raise your hand. If I'm too fast, ask questions, and otherwise, help me to go through 70 slides maybe. Let's see, that's the session title. It's going about Office 365 and cloud services. You know all these slides about the sponsors, which makes it possible to be here. That's something about me. I'm one of the MVPs for Exchange Link. I did a Link Master in the past. I'm maintainer of MSXFAQ.de, a German web page. Sorry for all the not German people here not knowing it. My idea to be here, why I'm here, why I'm talking to you. I don't get money for that. I spend only a lot of time, even for preparing the PowerPoints. I did a lot of network assessments the last 4, 5, 6 years, and I simply want to share my experiences, my tools, my tips. And I will tell you some things. I'm pretty sure that you all know already that, but it's hidden somewhere in the background, but it's essential for doing Office 365. And I start with the image. Think about trucks. Hey, come on, what's with trucks and network with that? Think about you are a gatekeeper at a factory exit, and you are counting the trucks entering and leaving your plant, and you are measuring the weight of the trucks. Okay, what's that with network? That's what network monitoring is doing today. Your simple network monitoring system is counting the packets on your router which are leaving your network and arriving in your network, and they are measuring the size of the packets, and all you get is megabits per second on fancy new graphs done that every minute or what else. The problem is that a valid approach to measure your network? Normally not, because think about there's a traffic congestion somewhere on the autobahn and no truck is arriving at your network. All you measure is the network is available, it's free, we have no congestion, it's not working like that. So, and if you ask your carrier, they don't provide you a live map like Google is doing that on your Android phone, for example. So we have to change our approach to measure our connection to the cloud. So let's talk about that. 5, 4, 6 years ago, the most customers were asking me about, we want to go to the cloud. How many bandwidth do we need? How many connections do we need? Can you certify our network that we are ready to go to Office 365? I said, okay, let's start monitoring your network, counting traffic on your Exchange server, check your SharePoint server, measure the amount of data and calculate the usage with Teams or Skype for Business Online during that time frame. And that was the nice time 2, 3, 6 years ago. And then we had COVID. A lot of people were traveling to the home office, and the company had two problems. One is the home office users need a VPN connection to the network. And suddenly, a lot of my customers are increasing their internet bandwidth without any question. So I was talking hours and weeks about we need more bandwidth, we need local breakouts, we need, and they always told me, can you calculate that, how much it costs, and is it worth to spend the money? And then COVID was there and no question anymore. And a lot of people were using meeting platforms on premises like Skype for Business on premise, and they detected bandwidth is not enough, we have to do something else. So they were talking about split VPNs, about local DNS breakouts, and they were using Teams. So that was great. We had Teams adoption sometimes within 4 weeks. A company with 15,000 people switched from Skype for Business on-premise to Teams Online without any questions, no education, no change management, no user adoption, because otherwise they could not sell anything. And this summer, the company starts to go back to the office. Their problem was the people are not changing their way to work. They still use Teams, they still use OneDrive, and now they are sitting in the office. And we again have the problem with the bandwidth. But now in the other direction. It's no longer from the home office using VPN to the company. It's now working at the company side using the cloud services in a volume you did not even expect 3 years ago. And Microsoft tells us some things. I think we will see now 3 slides from Microsoft, and these are the only slides from Microsoft. One is, think about your IP addresses and remote systems you have to prioritize. Don't use your local network, try to use local breakouts, don't use cloud proxies or something like that, and don't try to do deep inspection on your cloud traffic, because the cloud is not the internet. Your tenant is your second data center somewhere else. Has any one of you a firewall between an on-premise Exchange server and your on-premise Outlook? Normally not. There's nothing in between. You trust them. So why is Exchange Online something else? And the second slide from Microsoft, I have all these links on that. You will get the PowerPoint later on, so no, you do not have to write them down. And here are some more links. I simply switch about that. I told you 70 slides should be something I should go further really fast. But let's talk a little bit about the Microsoft network. What's behind? What's that global network? Also some counters here about the Microsoft infrastructure. Some things you can simply do it on your own. Ask the RIPE about the subnets and the IP address, and you can see during the last thing I checked that Microsoft had about 20 million IPv4 addresses. It's simply visible from the routing table. But how does that work in your company? Sample, we have home office, headquarter, and the remote location. And our headquarter had an internet connection 2, 3, 4 years ago using an ISP, using the internet. And you can use this connection to the Microsoft network. And the first thing you have to check is what's the peering between your ISP and the Microsoft global network? Is it using a global internet exchange point? Or is there a direct link between your internet service provider and Microsoft? Something you can simply find out using traceroute. Then let's talk about the Microsoft network. It's not located in Europe. It's not located somewhere. It's worldwide spanned, and it's a network maintained by Microsoft. They told us they do quality of service, they have low jitter, and they have no packet loss. Okay, sounds promising, but we have to believe because we do not have a deep information about that. And all the data centers are connected to the global network. And now let's go it with other people. You're in the home office. Your home office also connects to the Microsoft network, but it's using another ISP, normally. Your home office ISP is something else. And your remote location could be in another country, in another continent, and you will also have another ISP for that. And now, simply keep that in mind. There's a thing Microsoft told me, it's called hot potato principle. I'm not sure if you ever, you know what a hot potato is, if you have it in your hand. Yeah, question?
I know what a potato is.
Okay. Hey, one guy knows how to raise his hand, thanks, and one is alive. Okay. A hot potato means if you have it in your hand, you do not want to hold it for long. You want to take the next one. And if you think about the internet, and I'm in my home office and I try to order something for Christmas from Amazon, what else? The packet is traveling from my ISP to the shop, and my ISP tries to get rid of that packet as soon as it can, because why should German Telecom transfer that packet for a long time? Because they have to pay the bandwidth for that. So they try to find the earliest peering to get rid of that packet. Microsoft is doing differently. Microsoft says, hey, our customers are paying for us. They pay a lot of money, not only for Office 365, also for the network. So Microsoft uses their network to shorten the connection to you as a customer. So Microsoft has a lot of peerings, and one idea is the internet here is no longer a long path which is uncertain and unreliable. The best solution is you use your company network, go to ISV, and the internet service provider is connected to Microsoft. So this part of the internet is not really very long, and it's in the best way, it's within your single service provider. But then we have still our problem with the remote location. If you use a local breakout, for example, that's what Microsoft recommends, then your PC at your office or at your home office, wherever, leaves your managed network. I hope the network here is managed for you, and travels through 2 or 3 hops using your preferred internet service provider, and then runs to the Microsoft global network. And that's full managed and reliable. We had samples, for example, in my network assessments. There was a remote location in Dubai, and the latency from Dubai to Amsterdam to the Exchange mailbox was 10 milliseconds faster than from Dubai to the German main location using the MPLS network. Amazing. So there's a lot of bandwidth, and it's always a good idea to break out very early to the internet and then let Microsoft do the rest. Microsoft has a lot of peerings, and by the way, you can build your own peering to Microsoft. The policy is public. There's only one problem as a company. The minimum bandwidth is 10 gigabit. And if it's utilized about 50%, you have to increase the bandwidth. So it's nothing you can really do as a normal customer. But if you're a normal customer, you can have a look what else is possible. You can use your normal ISP, and so I missed one slide. And there are other carriers around offering something like a fast pass to Office 365. So Express Connect sometimes is a name. So think about that. What you should do as soon as you're at home, do a trace route and check for the first entry point with MSN.net. Because that's the first entry point in the Microsoft network. It should be fast, should be maybe no more than 6 or 7 hops away, sometimes a little bit more, but check the latency about that. This was in the hotel that morning. We can do the same here. I think you know how to use traceroute. Second story, domain name services. Take the same picture, and we know that the client is asking your domain controller. I think that's the common case mostly everywhere. Your domain controller may ask your firewall, your DNS forwarder, what else, and normally they ask your ISP. Sometimes you ask the root servers, it doesn't matter. And at last, the question goes to the Microsoft, where is Outlook Office365.com? Outlook detects, oh, the source IP address is the following carrier. Let's give him the right answer so that we use the right peering. And now think about your remote location. So who's managing a company with multiple locations? Some hands up. Okay, I think some more. What's your client doing in the remote location? It asks the remote domain controller, and the critical question is now, your domain controller on the side, which is the next DNS server this domain controller is asking? Is it using the local breakout to the ISP here, or is it using the central DNS server? About 60% of my assessments, the remote location is asking the central DNS server. So think about, I'm working here in Germany. My main site could be in the US, and I'm asking, I want to connect to Outlook Office365.com, and I'm asking the domain server in the US. What do you expect? Microsoft gets a query, a DNS query from a server in the US, and the entry point is the US. You don't believe me? Simply let's test it. I simply do a lookup to Outlook Office365.com. I'm here in Germany. I'm using the standard DNS setup, and I know, hey, I'm in Frankfurt. That's fine. Now let's ask a DNS server somewhere else. It takes a bit longer, and you see MDB. Who knows what MDB is? MDW. It's very easy. You take your browser, and then at the flight area code, that's Chicago Midway. So a simple stupid DNS query tells me my client would connect to Chicago to connect to my mailbox, which is still in Amsterdam. So check your DNS setting. Let's talk about the remote user. I have a lot of arrows here, so I'll try to explain. You're a remote user at the home office. You have a VPN established. Your VPN is routing everything to the company network. Which DNS server is asked by your VPN client at home? Which is on the company? Hands up? No? Okay, some. Think about how is your Outlook performance if you're connected, for example, to German Telecom, and your carrier is maybe AT&T, and your client is asking your on-premises DNS server. This is asking Microsoft, and Microsoft detects, oh, an incoming query from an AT&T customer. Let's use the entry point in somewhere. And then it could happen that your client connects to your ISP in your home office and uses the peering to the other ISP to use this peering to the Microsoft network. Not what you expect. What are you doing if you say, okay, how can I make sure that my client is asking the local DNS server, but I want that this client is resolving internal IP addresses? How can you do that? Someone aware about a name resolution policy table? Have you ever heard that? Who has heard name resolution policy table? No one? Someone using direct access?
Windows.
Who uses direct access? And you never heard about NRPT? Okay. Long story short, NRPT means you can use a group policy to specify which domain should be resolved using what DNS server. So you can tell your home office client the default DNS server is your DSL router, but company.local, company.de, what else, that has to go to the DNS server in your company using the IP VPN. Because otherwise, if you use a VPN or direct access, every query will go to the company, and the company will give you the answer of the best entry point for the company link. Who is using split VPN? So what do you expect from your performance? It's suboptimal. But Microsoft knows about that, and Microsoft tries to make that better. Who is using IPv6 inside the VPN? Okay, who is using tunnel VPN? Have you ever done a trace route using IPv6? If your VPN is unable to handle IPv6, what's the default gateway for IPv6 on your client? It's not the VPN tunnel. 50% of my network assessments with people claiming me, we have a tunnel VPN, we don't like local breakouts. I simply showed them, funny, but your Teams conference is not using IPv4, it's using IPv6. Even Outlook can do that. And the IP stack simply uses the routing table of your PC. And if your VPN software is unable to change the default route for IPv6, there is no default. The default route is your local DSL. It's a surprise for some firewall admins, by the way. Third misconfiguration, there are customers who don't trust the ISP and they don't use the root servers. They use other kind of DNS servers, like the Google DNS servers, or maybe some pie holes in the internet to get rid of this advertising, all of that stuff. And sometimes these servers are located in other data centers. So think about, you're here and you ask another server. So what's the answer? Let's have a look. So I do the same again. You see, I'm currently located to Zurich, sometimes in Amsterdam. And now let's take some other DNS servers. That's Frankfurt now. So it depends on the location where you are. Microsoft uses GeoDNS for many cases, not for all. I will follow up on that later, to find the best entry point for your client, and that's about it. Okay, that's my backup slides in case that something is not working here. So make sure that your clients are using the right DNS server, and make sure that your DNS resolution runs the same path as your IP address, as your IP routing is going. Watch about VPNs, watch about IPv6, check about some optimizing stuff. One interesting story, I did this test in the Radisson SAS here in Düsseldorf. The fun story about that, if I do it here, I get answers about 100 milliseconds. So this DNS server is really far away. Anywhere aware what 114 is? It's a public DNS server in mainland China. There's a second one, but it's yeah, why not? It's helpful. If I do that in the Radisson SAS, I get a reply after 3 milliseconds. Because DNS is not encrypted, there is some kind of firewall. See, that's a DNS query. I will grab that and route it on my own server. So be aware that the DNS server which is answering is the right one, because we have things like riverbeds and others around which may optimize your traffic in a way you did not really know. So what's the problem with that stuff? Microsoft has a solution for that, but not for every product. Anyone aware about Anycast IP routing? Think about the following. The normal internet. We have one server here, we have a client, and we know the internet is built of a lot of routers doing redundant paths using border gateway protocol. So if one router fails, nothing should happen, normally. And if a company wants to be better available, they have two ISPs. They have a provider-independent subnet, and they use BGP to publish the routes through multiple entry points, and it's high available. So if one router here breaks, the next router forgets this route and uses the other path, everything is fine. And what happens if I use a knife and cut it in between? And I put many servers around the world with the same IP address. You know, an IP address should be unique on the internet. Not every PC must have a single unique IP address, but that's wrong. You can have multiple of these. No problem. The only thing you should know, every server should give the same answer, and then you don't care. And that's a trick behind, for example, the Google DNS servers, the 8888. They're distributed around the globe. You can use a PC wherever you are. You can ping that machine, and you will always get a latency from 5, 10, 20 milliseconds. I've never seen one with more than 100, and as soon as you travel to Asia or to United States, 100 milliseconds is usual. So some services are around the world and have the same IP address. And the question now is, which Microsoft service is doing that? Let's test it. So you have seen it with, for example, with Outlook. You see different names, different IP addresses. Let's have a look how it works with Teams. You see these IP addresses? And let's now ask a server in China. Compare this and this. Let's add another server. The same. If you want to have something, the Germans are more scared here. There's a web page called Unfiltered Serving, and that's a number of DNS servers in the internet who answers your requests wherever you are. So whenever you want to ask a server, for example, in Brazil, where is it? Brazil is here, and I'm not sure if that's working, but I simply can try it. So let's ask a server in Brazil, a DNS server. Sometimes it's working. So you have seen that the answer took very long, but it's the same IP address. And I'm pretty sure that the Brazilian guys are not connecting to an IP address in Europe. So let's go back to that. Exchange Online is using GeoDNS. I think Microsoft is doing that because there are a lot of clients out there, Thunderbird, IMAP clients, what else, who may have problems with Anycast DNS because the server can change with every request. But SharePoint is using Anycast, or at least for my tenant. So if I do a resolution to my tenant wherever I am with every DNS server in the world, I always get the same IP address and the same DNS CNAME. Teams is doing the same, but not for real-time media. So Teams, one stack is the HTTP stack, the other one is the RTP stack. So simply have that in mind. DNS is important, but for SharePoint and Teams and OneDrive, Anycast DNS will hide misconfigurations on your local site. But you should still check, is that everything fine? Okay, let's go to other. I tell these a thing, you already know that. Latency and throughput. Think about the following story. I have a PC here, I have a wide area link, I have a server, everything is unlimited. Only the latency between the two sites due to the distance is 20 milliseconds. And you do a file transfer using FTP. Single TCP connection, simply transfer a big ISO file. What bandwidth do you expect? Who thinks 100 megabit and more? Hands up, please. 10 up to 100? Okay. 1 to 10? So some people are no more than others. So let's have a look what's going on. Let's start a simple assumption, which is wrong, but simply to start the argumentation. Think about a PC sending an Ethernet packet with 1.5 kilobyte to the remote site. It's traveling 10 milliseconds on one direction, 10 milliseconds on the other directions. So it takes 20 milliseconds to transfer 1.5 kilobytes. with 20 milliseconds between each packet, you can have 50 packets per second, which is, you can read it. That's not how TCP works, but that would be the case if it's a stupid TCP stack. But we have Windows. So we can say, come on, let's send a lot of packets and send the acknowledged messages later. So the first question is, what's the largest window size? How big can this size go? Because your sending PC has to maintain a memory for that. Because if a packet fails, it has to resend it. And even the receiver side has to maintain a buffer, because a packet could fail and then he has to wait for the remaining packet to get delivered to forward it. And Windows 2008 has a maximum limit of 16 megabyte here. Even some firewalls are optimizing that because they have to maintain the same buffer to do a deep inspection. And even web servers are optimizing that. Think about, I'm a bad guy. Hi, web server. I would recommend a buffer from 1 gigabyte. Here's packet 1, here's packet 1 million. Oh, the others are lost, sorry. And the web server, the IP stack, has to maintain a buffer for the waiting packets, which could open denial of service attack if you do not have an intelligent IP stack doing that. And let's talk about what's reality. So I did my Wireshark, started some connections using Exchange Web Services, did an Outlook OneDrive upload, SharePoint download, some other stuff. And these are the window sizes which were negotiated. So a SharePoint download did a 4 megabyte window size. If you are on premises, latency is not a problem, but think about 20 milliseconds. If you have 20 milliseconds and you can transfer 1 megabyte per 20 milliseconds, then you can maximum reach 50 megabyte per second. And 20 milliseconds, that's pretty fast. Think about other directions. And now think about the Outlook client connecting to Chicago because you have a wrong DNS setup. And you are talking about 100 or 200 milliseconds. And the effect for your bandwidth, for your reaction of Outlook. So latency is the key, not bandwidth. And if that's everything, we have talking about TCP. What happens if you lose a single packet? If you use a single packet, the recipient will stop streaming the data anymore and say, stop client, I have to you request a packet, and so on. And the sender on the other side will detect, oh, the remote side is asking for another packet. There was a packet loss. Looks, I'm sending too fast. I will throttle down because I don't want to force more packet loss. And now let's talk about VoIP, about Teams. Teams prefers to use UDP instead of TCP. Are you sure that your firewall is open for UDP ports? 50% of my assessments told me, no, we are not open. We don't trust UDP. UDP is not firewall friendly. You have no stateful inspection. UDP is dead in the security stuff. But in reality, what happens if you block UDP? I'm talking, Teams is transmitting, and there's a single packet loss. And the remote side has to request the missing packet because it's TCP. And during that time, the remote side cannot hear any audio anymore because every packet which was already received have to wait for the missing packet. It's TCP. If we use UDP and the packet is lost, who cares? 20 milliseconds, no audio, gone. Do I need a packet which is half a second old? No, you cannot turn back the time. And now the question, if you have connected your network like that, a client going to the internet router and so on, we all know we can throttle the bandwidth, we can do prioritization on the outgoing direction. What's with the reverse direction? Do you need some help from your ISP to throttle down video instead of audio? Or can you do it on your own? Who thinks you can do it on your own? 1, 2. You can do it on your own. If you listen carefully, you can simply delay your acknowledged packets to tell the remote side, don't send so fast, throttle down because we have a congestion somewhere. And there are firewalls out who can do so. And that's a trick to prioritize traffic on your internet connection. Last story here, ICMP and blocking. I have seen customers blocking ping. We don't want ping. We don't want our users to map our network using ping. It's not really protection, it's more security by obscurity, but anyway, they do that. Sometimes they may have an HP printer or Cisco router with ping of death. This is, I think, 25 years ago. That should not really be a problem, but they do it. But we have another problem. Think about the following. We have a client connecting to a server. The client starts with a synchronization package with 1,500 bytes. And my router here, because that's a DS Lite connection, tells me, sorry, that packet is too big. Use a smaller one. I send a smaller packet, and it's going through the internet to everything to the remote server. Okay, the server has to answer. The server also sends a packet with 1,500 bytes because the reverse direction has its own packet size. Everything is going fine until my provider tells me, sorry, the next hub cannot deliver this packet. It's too big, and we do not fragmentation here. So he sends back a packet, an ICMP fragmentation needed packet, to the sending server. And if your firewall says we don't like incoming ICMPs at all, the server will never get that control packet and the connection breaks. Simple situation, if you have Skype for Business on premise, audio is working because small packets. Video is working most of the time because small packets. Desktop sharing is not working. Check your firewall about ICMP blocking. That's something, and it only breaks on DS Lite connections, for example. That's just things like that. And if you have seen now latency, you have seen now bandwidth and throughput, what's the solution for that? Yeah, the solution is Outlook starts to open many ports. One for the mailbox, one for sent items, one for synchronization, one for calendar access, one for address book, for shared addresses. Open your Outlook, check the connection status, how many connections do you have? That's my live picture here. You see a lot of Teams connections, a lot of Outlook connections. Questions, what do you think? How many connections do a Office 365 client consume? Normally, 8 hours a day continuously. It's not working, not web surfing. Open a browser, check a website, closing it. No, it's continuously connection open. Your firewall has to handle that connection for a long time. And you have Outlook, OneDrive, SharePoint, Teams.
25?
Dreamer. The thing is, do you measure that? You should do so, because the problem with the network address translation in between for all these sockets is the router in between or the proxy server. Every connection needs a port, and no one is reusing an existing port. It's not possible. So, how many connections do your clients have, and what's typical? That's what the question I already had. There's a document from Microsoft about limitations for NAT support. The Microsoft calculation is 6 ports per client plus 4 ports peak. I don't know how old this document is, but in reality, I have seen 30, 40, 50 connections per client normally, average. So check your firewall if you can get the counters of active connections. And now the question is, how many outgoing connections can you have per IP address? It's a 16-bit area, so get rid of the lower 1,000, get rid of the upper 10,000 because the operating system reserves somewhere for its own usage, LDAP queries and so on. So expect about 40,000, 50,000 available IP connections per IP address. And now think about 50 up to 100 connections per client, persistent, continuous connection. You can add Intune for that. You can add endpoint protection connection, Windows Defender. Everything will add connections. Yeah, and then if you have 1,000 clients between one IP address, you may have a problem. And the problem sometimes is, yeah, Outlook does not get new mails very often. Or whenever I change my folder in Outlook, I get a new mail. Otherwise, it's lost. So some of these spurious problems, sometimes it's working and sometimes it's not working. So get home and check your firewall about the connection users and ask them, can we have multiple connections on our firewall? A NAT pool, for example. By the way, the same with direct access. If you use direct access, the same limitation with a NAT 64 and DNS 64 system. That's what we experienced with 2 years ago, people using direct access for VPN and using IPv4. If you have a lot of VPN clients and the NAT system is doing IPv6 to IPv4 translation, you run out of ports. I told you a lot about TCP already, about Teams, RDP, UDP, all of that stuff. There's a clear statement from Microsoft. UDP ports should be open. Blocking these ports is unsupported. Now you can go in the battle with your security officer and your firewall guy. Do you want to run an unsupported state or do you want a working state? Things like that. And also there are other limitations like latency should be less than 100 milliseconds. And even Google is telling you, for Google Meet, for example, the best way to test your network is do a ping against this host and do it for a long time, for example, 4 hours. And make sure that every single request is faster than 100 milliseconds. Don't do averages. Averages will hide everything here. And if you know about that, Teams, if you do one-to-one media, it stays intern. If you do it from 2 locations who are not routed, they are always using the media relay. And now think about what's the distance from you to the next Teams entry point. And if you have a conference, it's here. And now let's talk about homeschooling with all the teachers around. Who is fighting with the education situation with, we want our own Jitsi server or our own big blue button server. We have a school in our environment with about 20,000 people in the city, pupils, students. And I simply told them, you can try it with your own Jitsi server, but it will not work. Yeah, why? Think about 20,000 people, 10,000 people in a home office, 10,000 students using conferencing. Everyone is sending video or sharing, you see a shared desktop, and you have 1 megabit per connection, so you talk about 10 gigabits. Continuously traffic, less than 100 milliseconds latency, no buffer like file transfer, what else, real time. It will not work. And now let's come to the monitoring. I'm running a little bit out of time, I think. Let's have a look. Maybe it works. And in the past, you had your wide area network monitoring SNMP, you had your firewall with SNMP and firewall logs. You have your own servers, you have your own clients, everything is under control. That's what I hope. Reality is something else. But now we have cloud services. The services offered by Microsoft. There's no way for you to monitor a single server. It's not even worth to do so, because we at Network have about 130 employees with 130 mailboxes, and every mailbox is on a different server in the cloud. There's not a single mailbox on the same server. Simply do a get mailbox and query for the home server, and you will find that out on your own. Which leads me to a thing, what does outage mean? Is your complete company down, or is a single mailbox lost because the server is gone? Read the legal stuff. That's not technical. If you think about your network, you will not, if you have done everything right with local breakouts, local DNS, then you will not have a traffic on your internal network anymore for this load. But it will go to the internet carrier. And is here anybody who gets some deep insights from the internet carrier about their traffic utilization? No, I have never heard one of that. And you have more traffic on your firewall, so we have to adjust our monitoring. So, and what can we measure? The first thing, I have 3 common mistakes. People are measuring bandwidth. Forget about bandwidth. Latency is the key. I don't care if the German Autobahn is full with 80%. As long as I'm traveling fast enough to the next airport and I reach my plane, everything is fine. Who cares about the trucks on the left side from me and the other on the right side? If my lane is still available, that's okay. But if I'm slow, I can pretty sure that everybody else is also slow. So let's simply test latency, and latency is a measurement between 2 endpoints. So I'm not standing as a gatekeeper of my fabricant plant. I let a lot of small motorbikes running the same way. If a Teams user sends 50 packets per second for audio, where's the problem to send 1 packet per second for measurement? To make sure that everything is going right. The next is, why do you measure your router every minute? If you Nagios or PRTG or Cacti or all of these tools or Insinga, what they are doing, they are asking your router every minute, can you give me the number of packets in out, can you give me the bytes in out? Every minute. Do you ever see a 5 seconds outage, a 2 seconds overload situation, which will definitely hit your team's performance? No. You have to change that. You have to measure in shorter intervals, maybe every second or every fractal of a second, doesn't matter. And the third mistake is don't do an average. Think about a pizza service. If you are a cook and you want to deliver pizza to your customers, and you say the average time for delivering a pizza to the home office user is 10 minutes, then it could be that you have 5 minutes, 50% within 5 minutes, and they're happy, and the other 50% may have a pizza after 15 minutes, which is cold, which is not good. So the real case is, I want to be that 59% of my deliveries are just in time or faster than a limit to have a happy customer. So talk about percentiles. If someone was in math, it's not very common, but don't take averages. Averages is not useful. You have nice pictures, but no samples. So what I'm doing here, I have some endpoints we can test. You can do a ping, you can do HTTP, what else? And if you have that, you can ping your firewall to check internal problems. You can ping your remote side of your internet link to check the path to that. You can go to the entry point to the Microsoft network, or you can go to the Office 365 service, and you can do a simple ping. I have enhanced that a little bit. Keep in mind, ping is no ECMP like that. And so you can find thanks. You can find that's the hostess. Tell me 10 minutes left. And you can find a script like end-to-end ping, simply download it, start it. It's doing a ping every second and do some ASCII art to show what it is. And you can definitely see, by the way, I have no access to SNMP. I have no access to the firewall. I'm only a stupid end user and can see it looks like the network was worse in that area, better here, and best over there. And if you do that on multiple clients at multiple times and you compare that values together, then you can find outages, misconfigurations, bad access points, even bad network cables. That's the magic behind. And that's, for example, a Bellevue hotel 3 years ago with a ping. You see midnight, morning, breakfast time, a lot of packet loss. That was in Hamburg. In Frankfurt, don't talk about the German railway. Yeah, but be honest, I'm a PC, I have wireless to the access point, and that has an LTE connection to somewhere else. What do you expect? And for example, that's my home DSL time 3 years ago with 16 megaband, and you can definitely see when my children arrives back and starting YouTube video. Because it affects my video quality, because with 1 megabit upstream, come on, to be honest. It's no longer true. I cannot repeat that measurement because now I have fiber, but yeah, you see. But simply get the idea what you can do with that, and that's a Microsoft Guest network with about 3,000 MVPs in Redmond. Blue means best. Blue is better than green. If you do something else instead of ICMP, you can use HTTP, but you need some friendly endpoints. You need some URLs you can query. Don't try it with authentication because that costs a lot of money. You should find something with the throttling, and you can simply use that using these URLs. You see the size about that. And if you compare that together, that's HTTP requests because it's slower, it's TCP. You need a SSL handshake. And that's a comparison with ICMP. But if you go to the Bellevue Hotel, then it's interesting because you see here that the problem with the network, there was an overload. ICMP was not delivered within a second. Round trip time 1 second, keep in mind. And it was a packet loss here in that area. But you can see the Outlook performance or the HTTP performance was slower. So you need to measure both because only both give you the insight. Was the connection slow or was it really too slow that we have packet loss? There's a difference between you have packet loss or you're simply too far away like a German ICE. And that's a customer situation. The same test, I'm using a 700 kilobyte file. That's the SMIME control from Outlook Web Access. If you know the URL is here. This one. It's a 700 kilobyte file, and you can download as often as you want without any throttling or authentication. So if you want to do a denial of service attack against your wide area link, use a PowerShell script with 10 concurrent connections. deal. But here you can see this was a connection. Sometimes it took about 5 seconds to get these files, and sometimes it's less than 100 milliseconds. It was a very unstable line. No quality of service, nothing like that. It took some time for the network guys to find out what the issue was. It was a cable, by the way. And but with tools like that, you can have a continuous load again and again. They can trace it using Wireshark or what else to find out what's going on. Sometimes you have some funny results. If you pass that HTTP request, you can find the name of the front-end server from Exchange. And this was in December 2019, where I was really able to find when Microsoft starts the data center in Frankfurt and Berlin. Because the servers in Frankfurt and Berlin start to accept traffic in that time frame. The same with SharePoint, because that's a SharePoint conference, or was a SharePoint in the past. Are you aware that there's the X SharePoint health score property in every answer from SharePoint Online? So if you use that URL, layout somewhere else, and you get the header, you get that. And if you do that every second, you can do that every second, it's not authenticated, and you put that on a line like Power BI, for example, you can see the average latency and the time the remote SharePoint server spends. During that customer, he was complaining about bad performance on SharePoint, and yeah, the Microsoft TAM told him, if the health score is higher than 7, open a ticket, we will move your instance to another farm. But you have to know that there. And the same is for Teams. If you use Teams, how can I measure Teams? Every one of you, whenever you start a Teams connection, your client tries to find the Teams media relay. And the Teams media relay is something very easy. It's a strange name that's called az.tr.teams.microsoft.com. So I'm currently, if I would start now a Teams meeting, I'm in West Europe. Simply have a look. West Europe, other server. North Europe, West Europe. France Central. UK West, West Europe. If you check the time to live of these answers, it's below 5 seconds. So whenever you get it, you can do that millions of times, and you can count the number of Teams servers around which are offering connections to you. And the easy thing is, every client connects to the server and says, hey, give me a candidate. And the server tells you, you can have one, but please authenticate. That's all I need. I send one packet and I get an answer back. So I know the latency. And I know the remote server is reachable and it's working. So why not doing that every second? From every PC, from every client. To measure, is the connection there? Is it stable? How far it is? What's the minimum? The maximum, maybe the average, but I would better use the percentiles for that. So what you have to check is, if you think about Office 365, you have to, so that I try to come to an end, you have to do 3 things. First is, check your configuration. I nailed a few of the topics. There are much more, but I have only 50 minutes. So check the configuration. Errors I found is network boards, wrong default gateways, problems in the routing, wrong DNS servers, sometimes proxy servers running around, even patch levels which were wrong, RSS scaling disabled, Chimney disabled on the network, offloading disabled on the network, all of that stuff. Sometimes I wish I would have a program I can simply start and they check, everything done. The thing is, second one is, you need connectivity checks. Can I reach everything? For example, I would like to have a piece of software on every PC who simply checks, can I reach UDP 3478 Teams? If that's not possible, I'll hurt a lot because that user is using TCP and it will affect audio. Fun story here, we had a customer where the Teams guys told us, oh, we have not filed a change request to open that port. It will not work. My program told them, it's working. We were asking the firewall guys, hey, what are you doing here? The firewall asked, no, it couldn't be working. I have no change here. It's closed. Please check it again. It was working. I entered the subnet mask false, and we enabled Zoom some months ago, and the scope was too big. And what happened? 1 hour later, UDP was blocked for Teams because it was not part of the original change request. And then the alert arrives, whoop, Team is blocked, and then we had to issue a change request again to open the port for us. So things can change even during the runtime. Even a firewall update or rule update from Palo Alto, what else, can block things which were working in the past. So connectivity is important. Check it. Do an HTTP request against Outlook and get the feedback about the Exchange front-end server back. Which server was answering. It's a simple PowerShell command. It's nothing more than this one. Do invoke web request against the FAF icon and get the X front-end server from the headers, and currently I have, oh, GV, what's that? I've never seen that before. In Geneva or so, could it be? New data center, someone aware of that? I'm not sure. And the last story is durability. Don't measure every minute, measure continuously. Get the information about that. I have done a lot of scripts. If you search for end-to-end on my webpage, I think PowerShell is not German. You can use it. It's for UDP, for ping, for HTTP. You can play with that. It can write the results in CSV files and so on. But the story about it, I know how to use it. Maybe if you use PowerShell, you can use it on your own. The thing I'm currently working on, if you're interested, send me a mail, is something program like this. I can run in the library PC, and it hides about 30 checks in the background. It's doing continuous checks against the backend, and it allows me to do fancy things like that. That's my client in the office. That's my home office. That's when I'm traveling with the ICE. That's when I'm in a conference center in Frankfurt. That's the traveling back, and that's in the home office again. And if I have 4 clients, I can compare that together, and you see the green one is somewhere in a bad location. 250 milliseconds. Come on. Don't try to use Teams here. And the benefit is this program runs whenever the PC runs, so I'm not relying on any Teams CQD reports, because these are only available if you do a call. They are not available if you're out of a call. Sorry for taking 3 minutes more than expected. If there are any questions, I'm here around, even after the session. Everything is German, but you can use Google Translation for that. And as I know, that's ping, that's UDP. And I have also other scripts like measure CPUs. I can tell you stories about problems here. Unfortunately, I have not yet published it on GitHub. I'm not a developer, sorry. It's on my wish list, maybe Christmas or so. But there are other scripts which are not relevant for Office 365, like do a LDAP query every second and so on. But I can tell you horror stories about virtual machines who are not performing as expected, and performance counters were fine, and only the application performance is what counts. So it's nice if you have a measurement software in your data center and you measure the availability of your servers. But it's useless if the users are complaining about bad performance. So you have to put the measurement to the desktop. And the scripts are, here. It's not really a collection, but if you do the ping stuff and click on that, and you see some fancy pictures here, though, that's a script. Otherwise, drop me a mail. My mail address is nothing there, so it's very easy. I will put a mail address in the PowerPoints, and so you will have it there. It was a fast walkthrough. Normally, it's 6-hour network assessment presentation on customer on site, doing this presentation, and then going to the real desktop and checking if it's already like it is. And it's funny what you see all the times. And even well-known admins knows, oh, I know that about ICMP and MCU and all that stuff, but I learned that 10 years ago during university, and everything is working. Yeah, it's working, but not as expected. Okay, don't miss your next session. Or stay here now. Thank you. And don't forget to fill out the feedback evaluations. Sorry.